Okay, so we said that these are called bits. These are called bits. There are 8 of them together are called a byte. And a byte is a common unit for measuring computer memory. And then they have other byte-based units are shown here. So we have a kilobyte, a megabyte, a gigabyte. So these are all bytes, right? Terabyte and so on. So kilobyte is 1,000 bytes, a megabyte is 1,000,000 bytes, a gigabyte is 1,000,000,000 bytes, and so on. Okay? And you can, in terms of, remember that a byte is 2 to the, what is it, 2 to the third. So this is 2 to the third, anyway, I guess it's about 2 to the 10th. I'm not sure about this. Okay, let's go on. Okay, so we go on after talking about bytes, and now we're talking about data types, and we've already talked about some of them. For example, we talked about an integer, and we talked about a double, and we talked about strings. And we didn't really talk about date, but anyway. Okay, so again, we talked about integer, double, and string. So there are other types, other data types. So these types are not numeric. Right? These are not numbers, these are characters or strings. Character just means like a single character, like the letter A, the letter B, or Japanese kanji, or a Chinese kanji, or something like that. I guess it's not called kanji, Chinese character. Okay, so these are not numeric. And date, Boolean, object are not numeric either. Date is not actually considered numeric, it's just considered its own type. Because it doesn't really work like a number anyway. You don't really add 2 dates. And it's a little bit hard to talk about that. So we don't really talk about them as numeric types. And Boolean means just it's yes or no. So some variables can only be yes or no. Okay, and the value can only be yes or it can be no. Like here, the value can be any integer. Not any one, actually. It's limited. This is the size. It can be up to this size, so what is that? 2 billion and something, and down to minus 2 billion. Okay, so but a Boolean can only be so an integer can take on all these different values from here all the way up to here, but a Boolean variable can only take on 2 values, either the true or false. Okay, so that's it, but that's not a number either. This is not numeric. So these are not numeric and these are not numeric. These are numeric and these are numeric. So integer is numeric, double is numeric, and we have some other ones. So let's think about integer for a minute. So an integer is uses 4 bytes. But how big is a byte again? Remember we just said a byte is 8 bits. So an integer uses 4 bytes. That means it's 4 times 8, or 32 bits. In other words, 32 bits can represent up to 2 to the 32nd different values. Let me explain that. Suppose we have instead of, we just said we had 32 bits, suppose we only had 2 bits. So that means 2 bits means 2 spaces where I can only put a 0 and a 1. So what things can I put in those 2 spaces? Well, I said I can only put 0 and 1. So I could have 0 in the second bit and 0 in the first bit. Or I could have 0 in the second bit and 1 in the first bit. I'm having to write this from left to right. Normally I'd write it from right to left. Or I could have 1 in the second bit and 0 in this bit. Or I could have 1 and 1. And that's all. Those are the only possibilities, right? If I have 2 spaces and they can only take zeros or ones, these are all the possibilities. In other words, there are 4 possibilities, which is what? That's equal. I can't write power here, but I'll write it here. 2 to the power, I hope you know what I mean, 2 to the power 2, right? 2 to the power 2 is 4, right? 2 squared. So there are 4 possible sequences I can express there, and that's 2 to the 4th. How about if I had 3 bits instead of 2 bits? Then I could have 0, 0, 1. I could have 0, 1, 0. I could have 0, 1, 1. I could have 1, 0, 0. I could have 1, 0, 1. I could have 1, 1, 0. And I could have 1, 1, 1. How many is that? That's all. Those are all the possibilities. And there are, wait, did I get them all? Or am I missing? Oh, I could also have, sorry, 0, 0, 0. So there are 8 possibilities, which is, there were 4 possibilities. That's 2 to the 2nd power. If we have 3 spaces, 3 spots, it's 2 to the 3rd power, right? Which is 8. If there were 4 spaces, it would be 2 to the 4th power, which is 16. So if there are 32 spaces, that's 2 to the 32nd different sequences we could express. And each one of those will represent an integer. So there's 2 to the 32nd different integers we can represent. So that's where this comes from. Whoops. That's where this comes from. So that's where this comes from. So this 2 to the 32nd is this number plus this number. In other words, this number doubled. That's what 2 to the 32nd will equal. So these are the 2 to the 32nd different numbers or different integers that we can represent with 4 bytes. Okay, if this isn't clear, you can talk to me later about it, or you can look it up on the internet. So that's an integer. It reserves 4 bytes of memory. When you declare something as an integer, the computer will reserve 4 bytes. 4 bytes, remember, means 4 times 8 bits of memory for that integer. Okay, and that means you can store up to this many different values in it. Okay, now there's something, okay, so long, what's a long? Did we use long? No, we use double. Double can store up to, reserves 8 bytes. So that's 2 to the, 32nd times 2? So 2 to the 64th different values. Okay, so a double reserves twice as much memory, reserves twice as much memory as an integer does. Okay, now we also have a byte and a short. So a byte, we already know what a byte is. It's 8 bits of memory, or 1 byte of memory. And if you declare something to be a byte, it has to be positive. And it can only go between 0 and 255. Remember, 256 is 2 to the 8th. Remember, we had 8 bits. So that's 2 to the 8th different possible values. And that's 1 to 256, or 0 to 255. So that's a byte. A short is this. So up from down here to up here, it's just 2 bytes. So that's 2 to the 16th, right? 2 to the 16th different values. And it's this set of values from here to here. Okay, and an integer we talked about, a long integer is 8 bytes. It's this up to here. We also have something called a single, which is 4 bytes. We have a double, which we talked about, is 8 bytes, and its floating point means it represents, we use it to represent decimal numbers. And then we also have something called a decimal itself, and that's 16 bytes. So that's even bigger. And that will represent numbers from here. Remember what this means? This means this number, which is 7.9 or negative 7.9, times 10 to the 28th. Times 10 to the 28th. Did I get that right? Yeah, that's right. So that's a very large negative number and a very large positive number. This was actually, this number this number times 10 to the 308 and 308 this way too. So, but this is storing kind of less precision because we're only using this many decimal places, whereas this one we're using this many decimal places. So that's why this one takes more memory. Okay, then we also have character and string. Now we talked about string, which is basically just like a word or something like that, or a sentence. Maximum you can have is 2 billion characters in a string, which I think is a lot. And but the string, sorry, I said that wrong. So the maximum number you can have is 2 billion characters, and each character is represented by 2 bytes. So 2 bytes we can see here basically gives us this number plus this number, or I shouldn't say that, but 32,768 times 2, which is 65,536 different values. So that's plenty, right? Like for the English alphabet, we only need 26 characters. So we don't need anywhere near this much space to store one English letter. But if you want to represent Chinese characters as well, there's a lot more than 26 Chinese characters. So we take 2 bytes and we can represent lots of different Chinese characters with 2 bytes, right? Just depending on the sequence of zeros and ones. Each sequence of zeros and one can stand for a particular character. And then we have something like 65,000 different sequences of zeros and ones. So we could represent like 65,000 different Chinese characters, which I don't think there are that many. Okay, so we have plenty of space with 2 bytes for a character. And then, as I said, a string is uses up to 2 billion characters. So you can put up to 2 billion characters, and each character will use 2 bytes. Okay, so that's a string. And we character, did we talk about bytes, short, integer? Yeah. Okay, so there we have we've done everything up to here. Date uses 8 bytes, same as the double. And the dates that you're allowed to express are January 1st, 2001. That's surprising you can't go below that. Up to this year. Okay, and Boolean we said only requires 2 values. Now, I don't know why they use 2 bytes for a Boolean. You could get away with 1 bit for a Boolean. This is 16 bits. So it seems like a waste, but I don't have the answer to that. And then object is another data type, which is just it could be any object actually. So that's very undefined, very unclear. But if you don't specify that it's a particular type, one of these types, it will just define it to be an object, and that requires 4 bytes. Okay, we'll stop here and come back in the next slide.